In this video, we're going to go over how to find vertical asymptotes. So before we go over how to find them, let's figure out what an asymptote is. So your definition is in analytic geometry. An asymptote of a curve is a line such that the distance between between the curve and the line approaches zero as one or both of the x or y coordinates tends to infinity. So what does that mean? Here in all of these diagrams, you have your asymptote, and they're represented by a dotted line. And they're represented by a dotted line because they don't technically exist. And I'll show you that in later videos. But if you were to graph these, it will not show these imaginary dotted lines that represent the asymptotes. But essentially what this means is whatever your curve is, as it goes to infinity in one direction, in this case, along your x to positive infinity, it's going to get closer and closer to this line, but it will never, ever touch it. So again, as this one on your x goes to negative infinity, it's going to get closer and closer to that line. It's going to approach zero, but again, never touch it. Here, as your y approaches positive infinity, here, as your y approaches positive infinity or negative infinity, and then we have these right here where the x and technically the y are approaching positive infinity, and we have a slanted or oblique asymptote. And so those are our three different types. Here are our two examples of horizontal asymptotes. We have vertical asymptotes, and then one example here of an oblique. So let's focus on these vertical ones first. To find vertical asymptotes, they occur where the denominator is zero. Well, we just did that right here with domain. These domain of rational functions and vertical asymptotes are almost, not exactly, but almost identical to each other. So we have three steps to find vertical asymptotes. The first thing is to factor the numerator and the denominator completely. Once you factor, you need to cancel any common factors, and anything that's going to cancel, this is going to leave behind a hole in the graph. So this lesson is over rational functions, and this is over lessons 1 and 2. Lesson 1 is your basic rational functions, while lesson 2 is your advanced rational functions. And in advanced, that's when you're going to get some holes. So you will have no holes when you go over the basic or lesson 1. When you go to advanced lesson 2, you're going to have some holes. And so we'll go over how you get holes, but just know whenever you have any common factors that cancel, that's going to leave behind some holes. And then lastly, you're going to set the denominator equal to 0 and solve for x. So let's do some examples. All right, we'll keep our instructions right there. So example 2, find all vertical asymptotes. So step 1, you need to factor completely. Well, this is already factored, so check. Cancel any common factors. Nothing cancels. You have an x plus 4 in the top and an x minus 5 in the bottom, so those don't cancel. These are grouped together, and so either everything cancels or nothing cancels, so you can't just cancel x's there. So this one starts right here on step 3. We need to set the denominator, which is x minus 5 equal to 0, and now solve for x. So we'll add our 5 over, and we'll get x equals 5. This is my vertical asymptote. So if we were to represent this on a graph, we will come along here to where x is 5. And we would have a vertical asymptote right here, that's equals 5. Okay, on B, we need a factor, and in this one we can. I can't do anything with the top. But this bottom one here is a difference of squares. So to get x squared, you multiply x times x. To get 16, you multiply 4 times 4. Because it's the difference, to get that negative 16, you have to do 1 plus and 1 minus. Step 2 is to cancel any factors that are common. We don't have any. So we'll go to step 3, which is set the denominator equal to 0. So when I set this equal to 0, we'll do x plus 4 equals 0. Subtract your 4 to get x equals negative 4. And then x minus 4 equals 0. You'll get x equals 4. So this one doesn't have one vertical asymptote. It has 2. So if we were to graph that, we would come over here to negative 4 and 4. And we would have 2 asymptotes going through both of those values. Okay, C, we need a factor, and in this one, I can factor both of those. The top, that's a difference of squares again. So we get x plus 3 and x minus 3. Because x times x gives me x squared, and 3 times negative 3 gives me that negative 9. And if you're a FOIL, it will cancel out those middle terms. And then here we have a trinomial, but at least it's easy because my a is 1. So what multiplies to negative 21 but adds up to 4? Okay, hopefully you thought of x plus 7 and x minus 3. So step 1 is to factor, step 2 is to cancel any common factors. Both of these have an x minus 3. So now I am left with x plus 3 over x plus 7. So once we get a little further into this, we'll just keep in mind that we have a whole where x is 3. But for the purpose of this problem, we want to know where that vertical asymptote is. So I'm going to take my reduced rational function here and set this equal to 0. So we have x plus 7 equals 0. Subtract your 7 and we get x equals negative 7. So we come over here to negative 7. And there is my vertical asymptote. Okay, and then lastly, we need to factor this. I can't factor anything with an x squared. I mean, that's x times x, but that's not really going to help me here. This is a sum of squares, not a difference. I cannot factor this to x plus 1 and x minus 1. So I can't factor, which means I can't cancel anything now. So let's just take the denominator and set it equal to 0. We'll subtract our 1 and get x squared equals negative 1. To get rid of that square, we'll take the square root. This again is imaginary. When you get an imaginary number, that means here we have no vertical asymptotes.